Hello, everyone. Thank you for joining us today for the 5th edition of the Agilist Unlearning series. The Agilist Unlearning webinar series is a monthly event where we challenge the norms of agility as we practice it today. On this month's edition of the Agilist Unlearning webinar, we're going to tackle two important topics that impact Agile teams and their ability to ship quality products. We will be talking about demystifying DevOps and building a test-first mindset. So with no further ado, let's go ahead and introduce our first speaker. Our first speaker, Vivek Ganesan, is an Agile Practitioner, a Certified Agile Coach, Safe Agilist, and Scrum Professional. He is an author of 3 published books: Blameless Continuous Integration, Metrics for Agile Product Teams, and TDD for Spring Boot REST Microservices. Vivek is also a maker of 2 SaaS products, FaceQuest and Notesally, and his other passions include volunteering at Tech Coach Circle, and he enjoys writing about Agile technology and Agile software development. Welcome, Vivek.
Thank you, Jessica. Hello, everybody. It's nice to meet a lot of people, and we had a very nice conversation going. So just a quick check. Are you able to see my screen, the presentation screen, or probably okay? Are you able to see the presentation now?
Yes.
Perfect. Okay. So today, oops, I just have to. Yeah. So today I wanted to talk about demystifying DevOps. This is the topic. Basically, when we talk about DevOps, each person has their own view or own interpretation of what DevOps means because of good reasons. I wanted to take you through a ride of how DevOps came to be. And also, dejargonize some of the parts of DevOps, which people generally find it very techy. If you go to a ScrumMaster, if you go to an Agile coach, there are some parts of DevOps, some terms in DevOps, which people find it very techy and jargony. So I'm trying to, sort of dejargonize some of these things. So that's the goal of this session today, to give you a history of what DevOps, where it came from, and also to dejargonize some parts of the DevOps terminologies. Right. And my name is Vivek Ganesan. Jessica already gave a nice introduction about me. So I'm just going to pass through this point and let's get started. So today's agenda, as I told, is 3 parts. One is how DevOps came to be. It's a very interesting story, and desorganizing DevOps. And if there are any questions, we could take them at the end. Right. So what I am going to talk about in the DevOps and its curious origins is there are 6 scenes. Think of it like a movie which just has 6 scenes, very short movie that led to DevOps as a movement as it is today, right? And we are going to go through these scenes one by one. Why we are doing this? This basically helps people understand some of the nuances of what the nuances of DevOps which they can apply in their professional world, whether you are a Scrum Master or a manager or an Agile coach or even a developer to start with, right? So let's get started from here. So the first scene is basically pre-2000s. We call that the pre-Agile era. So the Agile as a word that we know today did not exist. So we call that the pre-Agile era. And a lot of people, if you see, I have taken some selected pictures of people, and these people were, people who developed software. Their daily job consisted of actually writing code and building software for their customers. One common thing about all these people were that some way or other, their software was called a failure. Their work was called a failure by their customers, by their managers, by different kind of people. And they were all frustrated about being called, somebody who created a failure work. And these people were in pockets, bits and pieces. They had developed their own small ways in which they can make it not a failure. And one common denominator of why those projects were failing is because there was a lot of time between the customer gave the requirement and the time the customer actually saw the finished product. So by the time the customer gave the requirement, multiple months and sometimes years pass. After that, they see the first version of the product, and the customer's life has changed. Customers probably even had, one or two kids on the way. After that, they are seeing the product, and now their entire world has changed, life has changed, their problems have changed. So probably at that point in time, after 1 or 2 years, they wanted a different software than what they wanted earlier, right? And then the customer said, oh yeah, it's good, but not so exciting for me. I don't find it very valuable. That's the feedback they got from customers. And so the projects were all called failures. That was not the only reason. There were other reasons, but this was the common denominator there. So these people came up with their own ways of, how they had a vision of how they could bring things better. And this person with a cool hat is Kent Beck. He created a system known as extreme programming, and he piloted it with one of his projects. And similarly, there are people who created Scrum, and there is a person who created a solid clean code movement, Bob Martin. We call him Uncle Bob. And these were the people, along with many other people, who had many localized different solutions for solving the same problem, which is customer does not want what he wanted 2 years back. So we need to work closely with the customer. That was the underlying theme. So this was pre-2000s, and it was still, the software projects were still called as failures majorly. Then came scene 2, which happened in 2001. For the lack of a better term, we call that as frustrated engineers meetup. Right? So all these frustrated engineers, they were not project managers, they were engineers who were frustrated because people were calling their projects failures and different problems they faced. They all met together in a ski resort in Utah. And they decided, okay, now that we are all here, let's try to find out ways in which we can all converge and create a way of work that can inspire other people to work closely with the customers. And that led to something called Agile Manifesto, which is basically a set of 4 values, and that was accompanied by 12 principles. This is what they created. And this is where the first usage of the word agile came in the sense of software development, right? So manifesto for agile software development is what they created, actually, which is called the Bible of Agile. If you talk about any agile professional, any agile coach, any agile trainer today, they will talk about Agile Manifesto as the Bible of the agile movement, right? It has that word today. And also what happened was, since these people created Agile Manifesto, the market started pulling that, and we entered, although slowly, into something what we call as era of agile transformations, where many organizations, they were also entering the digital transformations, where they were trying to move all their paper processes into computerized processes. And they found value of agile in that entire transformation from paper processes to computer-based processes. And there was a increase in the number of transformations that were happening, era of agile transformation. But the problem with that agile transformation was that most of the times the transformation were only based on process related changes and at most management related changes, right? They changed people, they changed management styles, they changed the process, but the core engineering they never touched most of the cases. But if you go to the 12 principles of this Agile Manifesto, the first principles itself has a heavy technical component. It says our highest priority is to satisfy the customer through continuous delivery of valuable software. So the continuous delivery is a very rad term today. Everybody wants to do continuous delivery, and it's something that everybody wants to do at the end of the day. But this was a term which was first used in 2001. So actual people, the initial people who created the Agile movement, Agile Manifesto, thought of continuous delivery as a vision for doing anything what we call as Agile, right? But actually this involves a lot of technical components, not just process changes and hiring a Scrum Master, hiring a product owner. It doesn't end there, right? Not just the first principle. If you revisit all the 12 principles, all the highlighted parts you see here have some technical component or engineering component along with it, software engineering component. And without changing any of these things, we were trying to run agile transformations without changing how the core engineering was done. And this created some problems because with people and processes, you can change a lot of things, but you can only go so far. You cannot actually go to a point where you can actually do a product which you can show to the customer every 2 weeks and get feedback and iterate faster. The technical component is needed in order to iterate faster. So this became a very visible gap right? This is where the software development industry stood at this point in time. Now, moving on to scene 3. This is where our hero enters. This person who is smiling, this guy is called Patrick Debois. And this guy was working as a consultant in Belgium. So at one point in time, Belgium government thought, okay, we have a lot of data in our data center and we wanted to do migration of data from one data center to another data center with probably higher qualities, higher capabilities. And they started a project in 2007. And this guy, hero of our story today, Patrick Debois, he was a consultant there. And one thing he felt he was frustrated was the conflicts between two groups of people, two groups of naughty people, right? One group of naughty kids was called developers. The other naughty kids group was called sysadmins or system admins or operations. And these two people never worked well with each other. But for any project, any product to actually go to production and perform properly, you need these two people, you need work from these two people to happen synchronously, right? And this created a lot of issues. And the problem was some people talk about this problem in terms of wall of confusion, where in the world there are developers and there are operations people or sysadmins people. Developers are the people who create new products. So they actually write code and try to push things to production. So their goal is to push more features to production. Whereas sysadmins or operators people, they are responsible for stability of the production environments. So their responsibility is to make sure that no untested code enters into production system, because if the production system goes down, then they have to probably come back to office in the midnight and do some troubleshooting and a lot of things. So what was essentially happening was that there was a wall. So developers created new changes, new products, new features, and then they threw them over the wall. So the operations people will catch it and put it into production and somehow make the production environment also stable in the entire process. So developers wanted changes, but operations people wanted stability, and they kept pushing back with a lot of checklists, lot of weird escalations, which basically made sure that these two people did not work together. And there were some organizational reasons also, because organizations also tend to create structures, reporting structures, which sort of enabled this problem. There used to be a VP of development and there used to be a VP of operations, and these two people would be political enemies, or they never talk to each other, or they basically always pass the blame at a leadership level to each other. So the same behavior was on the ground, and who was suffering because of this? The customer was suffering. And second thing, even the entire organization was suffering, because the customer could not basically get any reliability from what they are seeing from this organization. So because of all these problems, this guy was frustrated. Our hero, Patrick Debois, the guy who was smiling in the previous slide, he was frustrated. And this guy was actually more into operations than into development. And one fine day, this guy chose to attend a conference. That is where our scene 4 comes. So there is a conference that happens every year. So if you're an agile professional, start noticing start following a group called Agile Alliance. They run a conference every year called Agile Series. So they write the word Agile and they write the that particular year. So on 2008, they ran the Agile conference in Toronto. And in that conference, there was a notice of one session called Agile Infrastructure. So infrastructure is the ops word. And Agile was predominantly about software development. Even if you see Agile Manifesto, it spoke about software development. So there was one person called Andrew Schaefer who tried to marry these two things, and he wanted to create a discussion. So this guy put a poster on the notice board saying, hey, we are trying to have this as a discussion. Whoever wants to join this conversation is very much invited. And our hero went and saw, okay, cool, this looks cool, I'm going there. And he turned out to be the only person who attended that session. So there was, imagine a conference hall where only two people are sitting and talking in a international Agile conference, because the topic was about infrastructure and Agile. Not many people are interested. Only this person was interested, our Patrick Debois. And this created some more energy, and this created some more clarity into Patrick Debois' head. And he went back. He's from Belgium, remember, Belgium government. So he went back to Belgium and wanted to create a conference series, right? And he wanted nice ideas to be exchanged between developers community and operations people community. And he was struggling to name this conference, because any conference, in order to market it and in order to attract people to come to the conference, you need a nice name. So at one point in time, this guy thought, okay, I have two sets of people as target audience, devs and ops. So I am going to call the conference series as DevOps Days. right? The conference that brings developers and operations together. This is a very prestigious conference even to this date. Multiple countries are hosting multiple versions of DevOps Days. You can go to DevOps Days, has their own website where you can see all DevOps Days conferences happening all across the world. And this was the first known usage of the word DevOps, which means DevOps was not created with all the marketing hype. It was just created because somebody had a deadline to name a conference and they just joined two words, dev and ops. They created a word and DevOps Days came. And from there, the word DevOps started getting traction. So this person, Patrick Dubois, who created this name, did not know that he was going to create a multi-million dollar industry. He did not know that he is going to create a lot of tools, which will later say, hey, we are a DevOps tool. Any developer-based tool you see today, they are claiming that they are a DevOps tool because DevOps is basically a great thing that is valued by a lot of developers and engineering managers equally, right? So this was a term created by accident. So it is only just that there is no proper definition for this term. So we end up having a word DevOps which somehow picked up, but there is no common definition. So we entered that era. So somebody created a term, people liked it, but there was no common definition. So everybody and anything could be called DevOps. Just it's like blockchain, right? There was a time when everybody anything did was called blockchain related apps, and now it is metaverse. A lot of things. AI was like that. You put a if condition, that started getting called as AI because there is if condition is intelligence of the computer, right? So those kind of things started happening, and then the last scene is the scene 6. This is the last scene where a set of people gathered together and created literature which can help define the way the DevOps as an industry needs to go. There are two major works there. One is a absolutely super duper novel. It's a it's a page turner. So if you are interested in knowing about how software industry happens end to end, multiple different departments including security and the political struggles that any person has to go through in order to get things done, you can see this Phoenix project. It's a very super novel with a nail biting finish and all these things. So this was one of the works that defined what DevOps is. Along with the same person who created the word DevOps, he co-authored another book called DevOps Handbook with multiple other people. So this Jez Humble is one person who created what you say, who popularized the concept of continuous delivery. Right, these people got together and wrote something called DevOps Handbook, where they outlined something called 3 ways of DevOps, right? And this 3 ways of DevOps is something that later went on to create a definition for DevOps, saying if you do these 3 things, then this particular tool can be called as a DevOps tool, right? That's what this 3 ways of DevOps. So I'm not going to go in depth into 3 ways of DevOps, but because it could be a 1.5 to 2 hour talk in itself. But if you are interested about what DevOps actually means, you could go through this on your own. You can find a lot of articles online, very nice, nicely articulating these 3 ways of DevOps. And this is the official definition of DevOps for most of the world today. So we started with a point where DevOps was not even there. Some software architecture, some software development stuff was there, but we ignored it. And then this guy came, he created something called a DevOps conference. And then definition was not there, just the word was there. Then we entered into a point where somebody came and actually stabilized the definition of DevOps. So this is the running definition of DevOps in the popular community today. So this is where the history ends. So we now have something called DevOps. We now have a definition of DevOps, and this is where it starts, right? So this concludes the first half of what I wanted to talk. And the second half, now that you know the history, when a Scrum Master or a manager talks to their developers and they wanted to talk about DevOps, some jargons come in the way. So we generally call this as continuous this, continuous that, and whatnot, because most of the DevOps jargon start with the word continuous. So they'll say continuous integration, continuous development, sorry, continuous deployment, continuous delivery. A lot of jargons come in. So I wanted to attempt de-jargonizing some of these jargons so that you can go back to your teams and appreciate what they are doing and probably contribute to a conversation in these areas. That's the idea here. So the first jargon that I wanted to de-jargonize is called continuous integration. And this continuous integration is a common confusing jargon for a lot of people because it sounds daunting sometimes, right? First of all, it's a very big word. or 2 words, and it looks fairly technical, and people think, okay, hey, it's very technical, let's not talk about it, or let's not go deeper into it. Whereas actually what happens is it's a very simple thing when you split this into 2 parts, continuous and integration. So integration is nothing but combining two different or one or more things into single thing. That is integration. That is common English. Everybody knows that, right? So what happens is that when you develop software, a single person does not develop software. It's multiple people sit together and develop software, and each person creates their own part of the software. For example, one person can take one feature, another person will create another feature, another person will create the third feature, and before actually giving it to customer, we need to integrate all this code into a single working product before giving it to the customer. And that integrating multiple people's code into a single working product is called integration. Nothing more, nothing less, right? This activity is called integration, where you take code created by multiple different people and integrate them and make sure that it works as a single working product before giving it to the customer, before making sure that the customer can use it. Now, it can be just 2 people writing a single software, or it can be 5, 6 people writing a single software, single team. And if you're a big organization, it might be multiple teams creating the same software, same product, which means you have to integrate the entire, let's say, 10 teams worth of work in order to create that software. I was in such a startup where, we had to take 9 teams work of, 1 month or 2 months and integrate them and give it to the customer. That was the kind of work. So integration is nothing but combining multiple people's work into a single working product. Now, the word continuous means it talks about how frequently you do it, right? So in the pre-DevOps or pre-Agile days or waterfall days, what we used to do is multiple people write code, but they don't integrate it very often, which means features are all in different places. If you are interested in learning Git, there is a software called Git where each person had their own branch, and that will work fine, right? And they will never attempt to merge all these code into a single working product until probably somebody comes and says, hey, you know what, next month is release, let's start integrating today. So it will be a month time or sometimes 2 weeks time before somebody starts the integration. And I am running already 2 weeks into the deadline, and I'm integrating today. What happens is that these codes may not integrate well, and it causes a lot of problems. My code may not work with someone else's code. So their code will break the moment my code gets into the way. And sometimes someone else's code may actually stop my code from working well, right? Multiple combinations are possible. And since this code was running for a very long time, 8 months, 9 months worth of work, you're integrating after 8 months, it is very difficult to even debug and find out what is causing this problem when the integration is failing, right? And it then we enter into a phase called black box of integration, black hole of integration, where you don't know when you will come out of it. Then the projects get delayed. That was one of the main reasons why many projects got delayed beyond the deadline. And continuous, what we are trying to do here is, instead of integrating only towards the end of the delivery or only towards the deadline, integrate every day continuously, or at least every single change that anybody makes is continuously integrated with whatever is already there. That is continuous integration. There are many tools which help you to do this. For example, Jenkins is one tool which many people use, where it runs a job every time any person pushes a new code. It basically puts the new code with the old already existing code, runs some test and make sure everything works fine. This is continuous integration. So instead of integrating only before the release, integrate every day or every single change. That is continuous integration. Similarly, if we have to talk about the next, continuous delivery, we all know delivery. Delivery is like your Amazon delivery or food delivery, where you order something and it comes to your place, right? You order software as a customer, you want that to be there in your computer. You want that to be in the place where you work, right? That is continuous delivery. And previously, people used to deliver maybe once in a month, once in a year, and then they try to deliver once in a quarter or so. But in continuous delivery, every time any developer makes a change, it can be even a single line of change, it gets tested, and the final product goes to the customer immediately, right? Without stopping anywhere. There are no stopping anywhere, and it goes to the customer. That is continuous delivery. And the same problem, delivery is basically putting your software or your code changes to the customer, and continuous is basically how frequently you do it. So instead of delivering every year, deliver every single code change. That is continuous delivery. And these are also not common definitions. So each person has their own definition. This is the most common definition that I've ever heard, right, of continuous delivery. So for this also, again, many tools are there. Jenkins creates pipelines. We call them CD pipelines, where the moment a code is checked in, it will be compiled. There will be unit tests that will be run, and probably it will deploy it to some staging environment, and there will be some tests that run on the staging environment, and then it goes to the production, right, into to the customer's system. So that is continuous delivery. And there is another variation of the same term called continuous deployment. And continuous deployment is nothing but, again, split this word into two. We know about continuous. Let's talk about deployment. Deployment is nothing but the activity of pushing your code to some place where customer can access it. So moving the code or moving the finished product from my computer to the customer's computers, that is deployment. So if you're running a web software, if you're running a software that runs on internet, then continuous deployment is possible. But instead, if you're running, if your software is a software that runs on Android mobiles or iOS apps, you do not have the luxury to say, okay, force push all the new code into customer's computer or customer's phone. You cannot do that. Customer has to pull it, right? If there is a manual pull step or manual approval step needed either by yourself or by the customer to actually see the software, then that becomes a continuous delivery. Deployment is possible only when you can directly push it to customer's computer. That's the small difference there. And coming to next, and probably one of the last jargons, continuous monitoring. This gets thrown around a lot. What happens when we do software is that we stop when the code goes into customer's computer. But what DevOps teams do is they also put in enough metrics and measurement systems to monitor what happens on the production environment, right? So when some error happens, they want to detect it before the customer comes to them saying, hey, the error happened. So they want to be very proactive, and they also monitor that everything works fine as intended. The outages are immediately notified. So they basically build some softwares. They use some softwares in order to monitor their own software. So people generally use a stack called ELK stack, Elastic Search, Logstash, Kibana, Grafana. A lot of other tools come into play for doing this continuous monitoring. This is something that people do when they are entering DevOps. And one thing that I wanted to end with is, how does this relate to quality? All the things that we spoke about: continuous integration, continuous delivery, continuous deployment, and continuous monitoring. How does this relate to quality? All of these practices are needed in order to make sure that your code works well in the computer where the customer is using it. Your code works well in the mobile phone that the customer is using it, right? So that is why you basically make sure continuous integration makes sure that my code works well in my system also, and also in CI server system where other people's code is already there. Now, continuous delivery makes sure that you are running it in a staging environment and there it works fine. Continuous deployment makes sure that your code runs well in production environment, and even after you finish pushing the product to customers' hands, continuous monitoring makes sure that you will continue the same level of quality at the end. That is how these practices relate to quality. And why should developer bother about all these things? If an engineer is there, why should the engineer bother? Because this is a tool where engineers can take back their weekends. If they want to plan for a holiday, they actually go when these things are in place. They don't have to cancel their vacations because something failed in production. They actually sleep at night. They don't get calls overnight. If they want to go for a movie date, they actually go. These are the things that we tell developers. This is how what's in it for a developer? The question is, they basically can plan their life easily and they can live their life to the fullest when they basically promote and follow these practices. And that is what I wanted to end today's session with, and I'm happy to answer any questions that you have at this point.